Students, I am going to discuss a problem of rolling motion. The problem is a bullet of mass small m fired horizontally into a large sphere of mass capital M and radius r rests on a smooth horizontal table. The bullet hits the sphere at a height h from the table and strikes to its surface. If the sphere starts rolling without slipping, find h by r. Okay, so here is the sphere. Its mass is capital M and its mass of the bullet is small m. Let it strikes with the velocity v. Okay. Now, as the mass of the bullet is very much smaller than the mass of the sphere, so center mass of the whole system will not affect it as it remains on the center of the sphere. Okay. Now, as there are no external force as well as the torque, so in this problem, linear momentum and angular momentum remains constant. So, using conservation of linear momentum, conservation of linear momentum, we have mv, the momentum of the bullet, and initially the sphere is at rest, so it's 0. It will be m plus n into bcm. That velocity of center mass is this. So velocity of center mass equals to mv upon m plus n. Okay. Now using conservation of angular momentum about a point on the surface, which is actually the point of contact of the sphere. Okay. So conservation of angular momentum we have initially the angular momentum of the bullet about this point P is equals to mvh, and then the angular momentum of the sphere for the translation as well as for rotation. So it will be m plus n to bcm into r about its center mass and plus ICM to omega. Okay. Now here you substitute the value of velocity of center mass. This will be mv upon m plus m into r plus I, the moment of inertia of the system, the sphere and the bullet. The sphere is 2 by 5 mr square, and that of bullet which is at a distance r from the center of mass, so it will be mr square, and omega, this vcm by r, vcm divided by r. Here vcm is equal to mv upon m plus m. Okay. Now simplifying, we have h upon r is equal to 10m plus 7m upon 5 m plus n. Okay. Thanks for watching the video.